had a lot of emails about different queries for this homework, so I'm going to try and make the homework as easy as possible and try to tell you how to go with the steps ahead with the homework, because even I would understand that structural induction is not the best concept to understand in such a short period of time without looking at a lot of questions being solved. Just for this homework you're getting such a lot of help. Going forward, the chapters are easier and the questions are much more practical and you can visualize the questions. um, this homework is majorly about trying to write the mathematical function down. So let me just get really into it, and I'll keep it as short as possible and as crisp, right? So for the first question that you have to consider a set T is defined by two rules, that X is in T, and if T comma U is in T, then so is T comma U. So this, right? So let the weight of an element T in T be the number of times it is written, and rule 2 was used to construct it. List all the elements of T of weight at most 3, right? So I've shown the first two steps for you. The first one is X in T, right? So I'm just saying that weight 0 is actually X, just X, right? Weight 1 would become, according to rule 2, so if T comma U is in T, then so is T comma U. So here just assume X is in T, right? We know X is in T. So either one of these elements could be T, and so X comma X would be in T, right? The next one is weight 2, that is, now X comma X is in, this is the set, right? So now you have T comma U is in T, so then this becomes X comma X comma X and also the other way around. So if T comma U is in the set, then U comma T is also in the set. So this is solved with weight 2. Just try to answer for weight 3 here, right? That's the first thing for you. The second question is about subsequences. So a subsequence of a string S is a sequence of symbols from the string S in the order in which they appear in S. They're not necessarily subsequent, like not together, but it could be in an order, right? So if we write SS, that is subsequence of S for the set of all string subsequences of the string S, then for 101 you'll have the empty string, that is usually lambda, 0, that is just this one, 1 alone, 1 0 0 1 1 1. Now you have 101, right? So it can be written as 101. I cannot write this down as 110 because it won't be in a orderly form, right? So that was about not necessarily contiguous but sequentially, right? So it could be 1 1 and 1 0. If it was 0 1 1, I couldn't write 101. It would have been 0 1 1, right? Okay, so now we are supposed to define the subsequence inductively. So let's start with the base case. The base case is for the empty string. So the subsequence for the empty string would be the empty string itself. What about, the question now is, what about if you're given a string AS? So it is the subsequence of the string S, all the subsequence is with the string S or the character S. What about the character A? So this would be of the form of subsequence AS is equal to subsequence S union some format right here, and it would be of the form that A T belongs, so it belongs to the set S. Like, just try to fill in the blank right here. Okay. Third question is, this is the easiest one of them all, but still I'm going to go over them. Prove that the associative law is true for the expressions that were given. As I went over in my discussion section, you just have to like draw the truth table, draw down to the most atomic form that you can go down. So we go down to PQR, try to use all the use cases up, write the next closest or the next most simplest form of a logical expression, that is P or Q and Q or P, Q or R, right? So now you have all the ones written down. So I start with all trues, one false, two false, and it just keeps on going, right, till I get 3 false. So use these combinations of P, Q, R, try to answer P or Q, try to answer Q or R, you'll get these answers, right? So now just fill these two columns up using the same thing. So you have the answers of P or Q right here, or that with R, you'll have this one, right? And similarly for this, you need to understand what to do there. And just show that these two columns are the same, and you can show that they both are equivalent, and hence they are, hence you prove the associative law that they both are a tautology, or sorry, not a tautology, but like they both are equivalent to each other, right? So here you just prove the equivalence of these two columns. And the last one is using the language of truth functions, explain alpha equivalent to beta, right? So This is the most trickiest one that I found. So I'll just try to break it down for you. So a truth function would actually take an input of, let's suppose, of the form b1 till bk, where they all belong to 0 or 1, right? And the truth functions are phi alpha, phi beta, and they're usually written down as phi alpha and the inputs that are taken, right? So you write the same thing for beta, like phi beta b1 till bk, right? Now what kind of inequality would that be? If I have to say that alpha is equal to beta, alpha is equivalent to beta, then what will happen to phi alpha b1 b2 till bk and phi beta b1 till bk? So would it be like phi alpha bracket all the inputs is equal to, greater than, less than, equal to the other phi beta of that, right? So that's how you answer these. These are the 4 questions. Please be assured that we would give you appropriate provisions when we grade the homework, and I think this video should really help you. And in case, please feel free to reach out in case of any other queries. I have had a ton of queries for this homework, so I just thought the best would be to make the video. And please let me know in case I can be of any more help to you. Thank you. Have a safe weekend. Thanks.